Hello.
Hi. Sorry.
What room goes for?
This way.
No, that's one floor upstairs over here. Okay. Right, give me a moment to get set up here. So, what I started doing last year, my first year class, I only started 6 weeks into the program, was I started recording my lectures so that they're available on YouTube for posterity. So I'm going to attempt to do that from the beginning now. Obviously, we didn't get last week, but I'm going to attempt to do it. Hey, here we go. To get it done today. So we're going to see what this looks like. Probably what's going to happen is they go live, so they stream live now, or at least that's what I'm testing tonight, because YouTube are letting me stream live this year rather than having to use third-party software. So they should go live. There we are. Excellent. Now, let me focus that. They are not going to be perfect by any scale. However, you will be able to see roughly, if I flick actually over here, you're going to get this weird inset. No, actually you won't, because we don't have that. Sorry. We don't have a second HDMI cable on this machine, so you won't see anything. So we're going to stick with this. They're not going to be perfect recordings, but they should be absolutely good enough for revision. And it'll allow, again, if there's a tricky topic or something you didn't understand, or me, I was talking too fast, you can rewatch elements of it. My plan is to have them live, take them down, trim off the top and tail so the ums and ahs are out of the way, and leave it with something somewhat coherent. More than likely, because I take a break in the middle of the class, I will have 2 recordings per week. So I'll have a part 1 or part 2, so pre-break and post-break. That's how we're going to look. Okay. Last week, yes, it is correct. Great. Last week, what we had was I suppose, a brief introduction to the idea of programming as a skill. I looked at the idea of problem solving, and then we looked at the idea of, let's see, it's in reverse here on the camera, sorry. How can I do this? Nope, never mind. Okay, I also need to figure out how to fix the mirror image that's appearing there, but we'll work on that.
It's coming up alright online.
Oh, is it? Okay, excellent. Although it's really weird having me stream to your computer there 5 foot away from me. But anyway, we're going. Right. Actually, that's so distracting. I'm just going to do that. So we talked about the idea of programming, what programming is, which is essentially how we give a computer a series of commands in a specific order and in a specific language or in a specific format to get it to do work for us. And ultimately, that's what our goal is with computing, or computer programming. And then I went through very quickly what we would do from a course point of view, as in the topics we're covering for the syllabus for the 24 weeks. And I also looked at the assessments that you're going to have over the 24 weeks. Tonight, what I want to do is I want to spend the entire time of the 3 hours just doing a really small program, seeing how we can break it, why those errors are occurring, how we can fix them, and slightly augmenting the program. So we're going to start with our Hello World program, which is always going to be the first program we do in a programming language. It's incredibly basic. Its only goal is to get something on the screen so that you can say, oh, look, I've got something working. Okay. I don't know whether Angela has been in touch with you yet for your ELD or Effective Learning Development module. She is going to require, and it's incredibly helpful for the other lecturers, for you to upload an avatar, a picture of yourself for the profile. I've been working here for ages. I get some really weird pictures, student pictures, official student record pictures. There is one guy in 4th year, and his picture is an empty chair. So, general rule of thumb, right? Funny faces, pictures that are not you or that are artwork, they are really difficult to use as your student profile, okay? A much better idea is to kind of go with your standard passport photograph. It should be of you. It should just be of your head. We don't need these ones in the mirror, you know, where you're getting like a profile shot before you go out and night out. We just need a front-on picture of you without pulling a funny face, and just you, not a crowd of people where you're like the seventh person on the end. Because it just makes it easy to identify. It means that if you ask a question, and this is a reasonably big class, and this is only the second week that I have you guys. So if I get a question via email, I'm like, oh, who is that? I might know your name immediately. So I go onto Moodle and I have a look and see who you are, and then it might click, oh, I remember the question that they asked. So it's just, as a good rule of thumb, try to have a sensible photograph uploaded. Everybody nowadays has smartphones, so it should be pretty easy to do that. Okay, that's the preamble stuff. Tonight I want to talk about programming, and for this year, and kind of the common theme throughout Griffith College on our undergraduate degree is that we demonstrate programming through the language of Java. Java is one of many programming languages. There are a huge amount, even in the time that I've been a student or working in computer science, there has been easily 25 different languages that have passed through and have become popular and then have not been popular or have become niche. So you would only use that language for specific problems. Java has been in existence, I suppose. First time I heard of Java was in Windows 95. They had to release a second edition of it to allow for USB support, and then that's where they first included Java into the installation of Windows, or that Windows would support Java. So it's been around for about 20 odd years, 23 years or so. It is a versatile language. You can use Java to do lots of things. You can use it to do basic systems programming, like what we're going to look at this year. You can use it to do web programming. You can use it for applications. So for Android mobile apps programming, that's generally done through Java. It's versatile, but not necessarily the be-all and end-all of every language. Every language has their pros and their cons. There will be people who will tell you that Python is the absolute best language to learn because you can do more in Python by writing less than other languages. Some people will tell you C++ is the absolute best and only language you should ever learn. And the reason for that is it's so powerful. You have such great claws, talons into the operating system. You can do so many things, which is true. But the learning curve is really, really steep. And the things you can do and the ways you can mess up your program and the system your program is running on are large. They're vast the ways you can do that. There are other languages like JavaScript, which has become really popular now as the idea of a full stack developer, where you won't. JavaScript used to be how do you make like flashy widgets on the web page and drop down menus. And because of something called Node.js, it allows us to run JavaScript code server side, which means that behind the front end, behind the web page you're looking at, where the business logic, the actual functional programming is happening, we can use JavaScript there. And all of a sudden, the people who are only building user interfaces and we're only building the front end of a website can now work at the back end and can do really powerful stuff that way. Python's really handy. It does lots of things, but there are pros and cons to all of them. Java we've picked for a couple of reasons. One, it's versatile. It's able to do lots of different stuff. So we can do Java programming through years 1 through 4. And it's common enough. It's what's called a C-type language. It's common enough with other languages that what we learn here, how to declare a variable, how to declare an if statement, how to declare a loop, how to get it to read from a file, is going to be pretty common with most other C-type languages. So PHP or C or C# or C++. And there are several other languages as well. So it's nice in that sense that it kind of gives you a good general understanding of the logic of programs, but then also allows you to not have to relearn every time you start a new programming language. And you will start learning new programming languages. On this course, if you're here for the 4 years, in first year, you're going to look at Java. In web development, you're going to look at HTML, CSS, a little bit of JavaScript. In computer hardware, you're looking at a bit of assembly language. That's all the programming. In first year and second year, you'll do Java again, we'll do PHP. In third year, you'll do Python, we'll do Java again, and there actually might be some other mathematical languages like or. In fourth year, depending on what elective you pick. Hello. That is upstairs. Yep, that's upstairs there. No problem. There's a light switch just there.
101.
Beg pardon?
JS 101.
JS 101 for higher diploma in web development
Yes.
is upstairs.
Thank you very much.
You waited until the attendance got all the way around. Okay, just in case, this is first year computer science programming for BSC 1 or for the taster course, depending. Is everyone in the right room? Yep. Or is someone going to be too embarrassed to get up and wait till the break and then step in? We'll see. Where was I going? Yeah, so there's lots of different programming languages. When you get to fourth year, when you have the electives to choose, you look at languages like Ruby and Rails. You look at languages like C#, Python again, and there will be some machine learning stuff in there as well. So there's lots of different programming languages, and that's just in the 4 years you're here. When you go out into your career, if you're a developer, you may start as a Java developer, but in 4 years' time, you may be working on Python or on Ruby or on a language that hasn't been invented yet. What we want to get across in first year and for second year, third year, fourth year is that we're teaching you programming. The Java is a means to an end. I want you to be comfortable in problem solving, in taking a complex problem and being able to, just through experience and through your knowledge of programming structures, look at it and go, oh, I can see there are different parts inside that. And maybe I know how to do some of them, and maybe I don't know how to do others. And I'm going to start to build a plan of how to, first of all, decompose that large problem into smaller problems. Maybe some of those smaller problems need to be decomposed again, broken up into smaller pieces. And then I'm going to start working my way through each of those pieces, trying to create a digital solution for each of them so that I can piece it together like assembling a Lego set to actually be able to build the program. That's what my goal is. It's not learning Java, because the amount of Java we cover in first year, I could give you a single A4 page printed out and it would cover all the keywords. I could give you a single program and it would cover all the structure that we would need for first year. What I want you to be able to do is to solve problems. Java's the tool we're going to use for it, but problem solving is what I want. If we decided in second year, do you know what? We did Java last year. We're only doing C# this year. I should be able to give you maybe 1 or 2 3-hour lectures on here's what it is in Java, here's what it is in C#, and you should be good to go. You should be able to solve the problems the same way you did in first year. And we should be able to do that for nearly every programming language. So, like I said, we're using Java, but that's just our means to an end. Okay, yeah, so I've covered all of that. And this is kind of the key point for programming. There is always going to be a new programming language. There's always going to be a buzzword that recruiters are looking for. It needs to be a full stack developer. You need to have Node.js. We're looking for someone with AngularJS. We're looking for someone who can do app development for iOS or for Android. We're looking for tablet developers. Can you write a skill for Alexa? Like, if you start looking at recruiting websites and what type of jobs are out there, the buzzwords change every 6 months. There's always going to be new technologies. There's always going to be something else to learn. The fact that you're embarking now on a 4-year degree or at minimum on a 2-semester programming course means that you have an interest in learning about that area, but also you have started this path of lifelong learning. Computer science is not a field where you're going to finish 4 years and go, right, that's it. Never going to look at a book again, never going to learn anything again. You will always be learning something new. What we do in the 4 years is just to give you that solid foundation so that you can go out into industry and you can learn independently. You don't need to start a brand new degree every time a different language changes or comes along. So that quote there is basically, it's saying that there's loads of ways to solve a problem, but the principles of solving problems are finite. The principles haven't really changed in the last 60 years of programming. There have been new paradigms, new ways of programming. So, for example, we have gone from what we're going to look at this year, which is imperative programming, which is Start at line 1, then do line 2, then do line 3, then do line 4, then do line 5. Finish. To object-oriented development, which is what Java really is designed for. And we're going to look at more next year. But for this year, I want to get the foundation stuff really solid so that when we go to looking at objects, you don't need to worry about how do you do it and what's in it. You know that stuff. And then we've evolved from there to things like functional programming, which is, again, it's solving a problem. The principles are kind of the same, but the way you implement it is going to be different. It's like going from a petrol car to an electric car. They're both cars. Their goal is still the same. The principle of driving is still the same. Sit in the car, use a steering wheel, the brake and accelerator to slow and speed you along places, and use steering wheel to steer. But the engine behind it is different. If you're learn to drive in America, you probably learn to drive in an automatic car. If you learn to drive in Europe, you probably learn to drive in a manual car where you hit a clutch. And so there are different methodologies, different ways of doing it, but the principle's basically the same. Okay, here is our basic class. When we write a program, the first piece of our program, the first piece that we have written that's doing work for us is this class definition. We use the keyword class, and you'll see when I start writing code that it'll come up in a different color because it's reserved as a keyword inside the programming language. And this keyword class says everything from this bracket here to the closing of that bracket is my program. Okay, my program doesn't exist outside of those brackets. It's only inside those brackets. These brackets are, if you've never done any type of programming languages before, they look a bit weird. They're curly braces. I think it's probably the most easy way of defining them. When you see curly braces inside a programming language, they're defining an area. They're defining the scope of something. So here, these curly braces are defining the scope of our program. All of our program is within these braces. Above it and below it, that's not our program. We have here a class name, which is our identifier. It's our way of saying that's the program I want to run. So when we create a program, and the first program we're going to create is Hello World, we're going to go class, Hello World, and then we're going to open up a curly brace. And all of the code we need to get Hello World written on the screen is going to go inside these two curly braces. Okay, so that's the first thing. Every program needs, in Java, every program is going to need a class definition. If you don't have that, your program won't run, it'll just crash. If you have done programming before, especially if you've done an object-oriented programming language, so Java, PHP to an extent, C#, C++, something like that, you'll know where this is going. For the moment, for everyone else who has never done programming before, just take it that this is the way we define how our program is going. Eventually, we'll have multiple classes inside one program. And there'll be almost sub-programs that are running, and I can start one up and I can get information from that, and then I can shut that one down, but I always have the main program that's running. In the same way on your operating system on your computer. Windows is your operating system, but you can start up other programs that might exist on top of that. When we get inside the class, we have something called a method. A method is an element of functionality. It's a part of your program that does a thing. The thing it does will vary depending on what method it is. We're going to start off with one method, the only method that's absolutely required in all of our programs, which will be the main method, and I'll show you the code for that in a moment. But you can see here that we have our header for it, so what's going to define what our method is and how it works and what the inputs are and what the outputs are. And then we have our curly braces again. And inside, between the curly braces, we have our statements, however many of those there might be. We might start off with one statement, or we might have, by the end of first year, we might have 700 statements inside those curly braces. And they're the actions, they're the commands we're giving to the computer. So print this to the screen, solve this problem, store this number on the computer, ask the user for user input, make sure the user input is a number and not a letter. If it's a letter, ask the user to enter the number in again. Okay, they're the type of commands that we're going to be designing to get the computer to work the way we want it. If we put them all together, they look like this. We have a class at the top, and for us, for first year, we will only ever have one class. So every time we go to write a new program, we are going to create a new Java file, and we're going to put that program in a file on its own and save it. And so we want to run it. We run a specific command just for that program, and if we want to run a different program, we run a different command for that. Inside our class definition, we're going to have our method headers. We're going to start off with one, our main method, and I'm going to show you an example of that in a moment. But by the time we get to the first week in December, we'll be writing methods of our own. We'll be saying, hey, here's a collection of commands that do a specific thing. So again, that example of, I'm sure at some point everyone here has signed up to a web site, to a web form. They ask you to enter in an email address. And they validate that. They make sure that it's actually an email address you've entered in. So they look for two things when they validate it. They look for an @ symbol, and then on the right-hand side of the @ symbol, they look for a period. So that you could write whatever it is, dave@google.id. And as long as you have the @ and the dot, that's a valid website. That's a valid email address. Whether the email address is active is a different question, and they don't really care about that. But you've entered in a full email address. If they ask you for an email address and you enter in your phone number by accident, so 1, 2, 3, 4, 5, 6, 7, it usually comes back with an error. No, please enter in a valid email address. So we might say, hey, we're going to create a program that takes in information from the user. It allows them to a library program, and for registering, they need to have their name, their phone number, and their email address. And we might have a little block of code that says, when they enter in the email address, run it through this and tell me if that's a real email address or not. So it checks for the @ symbol and for the dot. And if we don't have that, it returns back, no, this is not a real email address, and it makes you do it again. So when we get to the 1st of December, we're going to start looking at how do we build those little sections on our own. I'm saying the 1st of December because based on my plan, we're going to do all the internal commands first, and then we'll look at how to compartmentalize it out to different parts. Okay, that's our template. That's a rough guide for structure on how every single program we're going to write between now and the end of April is going to look. But we need concrete examples. We need a blueprint is great, but you can't live in a blueprint. You need the actual house built for you. So let's look at an example of a program. Here is our first program. I have my class definition at the start. So class program 1. My program is called program 1. And I have my curly bracket up here. In the previous example, I had the brackets underneath like that. I don't normally write my code that way. I write it like that. The reason why I have it this way is to allow it to be really visual that we need an opening bracket here, and we need an opening bracket, and we need a closing bracket, and we need a closing bracket. It doesn't make a difference to the code. Okay, if you write your code this way with the line ending with the opening bracket and the line ending with the opening bracket, that's absolutely fine. If you want to write your code with the line and then on a new line, you open bracket, and then on a new line, you do the next line of code, that's also okay. The only thing I would ask is that you're consistent. You do it one way, stick with that way. If you do it another way, that's fine, stick with that. You can change from program to program, but don't change mid-program. It makes it very hard to read your code. And honestly, the reason why we write code like that, where it looks like we have classes out here, and then we come in a little bit and we do public static void, and we come in a little bit and we've got system.out, and then we go back out, and then we go back out. That has got nothing to do with making the code work. It's for readability. It's for you being able to look at your code and go, I can tell what's happening here. It's for me to look at your code and go, I can tell what's happening here. I can grade that code. It's for the other members of your development team to be able to work with you and to do it. It's for you to remain employed because you can write code the way the company wants you to write code. And we'll talk about how to do it and what the protocols are as we're going along. But let's look at this example. So I have my class definition here, and I'm going to call my program program 1, and then I'm opening up my curly bracket. That's my class header. My method header is this line here. Public static void main, and then we open up the brackets, and we go string, and we've got the square brackets, and then we've got args, and we close the brackets, and we open the curly braces. So by line 2, we've used 3 different types of brackets. And they all have different meanings in programming, and none of them are interchangeable. Okay, and I can see the faces looking back at me. You will get used to this really, really quickly. When we use the curly braces, it's because we're trying to encapsulate, we're trying to gather something together. So I'm trying to gather the program together, I'm trying to gather the main method together. When we use round brackets, it's usually for giving input into a particular command. So here is the command for printing something to the screen, and the round brackets are giving me where I put my input. What do you want on the screen? We'll put it in between the round brackets. The square brackets, for the moment, we're going to ignore and we'll come back to in February. We won't need them until February. The only time you'll ever see them until February is on that second line of all your programs. So what does this mean here? Well, if I ignore for one moment, if I ignore the first 3 words, this is the main method of my program. It's the starting point for the program. When you go to run your program, the Java virtual machine, the engine that runs the Java code, needs to know where it begins. And the main method is that signifier. We've all been in a supermarket, or we've all been in a park, and we've looked at that notice board with a little red dot going, you are here. And that's a guiding point. Okay, if I'm here and I need to get to the playground, I know that I go up and I take a right and I move around that way. So that's exactly what it is for the program. You start here and you follow the commands inside this block of code. And this might send you all over the file that the person has written, but you take your guidance from what's inside here. So that's what the main means. The first 3 words, we're going to come back to all of them, but in brief, this is what they mean. Public. This is a publicly accessible method. It can be accessed by any other piece of code in any other program. That's normal. Static. For first year, take static to mean that we will only ever create one version of this block of code in this program. And that makes sense. If our method is the main method, the starting point, you only want one starting point. If you give the computer a choice of 2 starting points, it then needs to decide. And computers aren't good at decisions. Computers are really good at following guidelines on how to make decisions. But if I give it a choice and I don't tell it how to decide, it's unpredictable how the computer's going to react. Void is a programming term for empty or for nothing. What it means in this case is we're not sending anything back out of this program. At the moment, that makes sense. This is the main method. This is inside these brackets here, from line 2 to line 4, or line 5. All of our code is going to exist. Every bit of work that our program is going to do is going to be inside these brackets here. So it makes sense that when it finishes, it doesn't need to send anything back. When we get to December, and we start looking at writing our own methods, we'll see that we can actually alter that. But for the moment, we never need to send anything back. This bit here is the bit that's most confusing because you come across reasonably advanced topics in your very first program and you're told, oh, just accept them. Don't worry about it. We'll come back to them later on. What that means is it will take in a string array of args, which is short for arguments. In plain English, that means our program can take input from numerous sources. We can take keyboard input, or if we write special code for it, we can take text file input, or it can take input from another program, or it can take input from a database or from a web page. All programs that we write have to have the ability of taking input. Even if we don't use it, the way Java is set up is it assumes it'll be an interactive system. You have to have the ability to have input in the same way you would have to have the ability to print things out to the screen, to have output from the program. The second line here, for every single program you write for this year, that remains exactly the same. Okay, it'll go public static void main string brackets args. Every single one, exactly as it is. For every program you write, the first line, only the first word will remain the same. This is going to change for every single program because as you have a new program, you go program 1, then program 2, then program 3, assignment 1, assignment 2, assignment 3. It's what you call your program, how you identify it. It's also worth noting on this entire line, the only capital letter is this S here. And in programming, capital letters matter. The case matters. If it's lowercase, it's meant to be lowercase. If it's uppercase, it's meant to be uppercase. They're generally not interchangeable. Usually, if you, like for example, if I spell public with a capital P, that's going to cause the program to crash. If I spell sys or string with a lowercase s, that's going to cause the program to crash. Sometimes there are exceptions. It won't cause the program to crash. However, it will give you really weird outputs. So pay attention to the case, to the context of the text here. Lines 3 and 4 are identical. So I'll explain one of them and then the other one's the exact same. System.out.println is the command to print something to the screen. Every time you want to print something to the screen, you'll write system.out.print or .println. And I'll explain the difference in a moment. This S here is capital. It is the only capital letter in that command. This character here is a lowercase l. Okay, this is print line. What that means is print whatever's inside the brackets and then move on to a new line afterwards. So if I wanted to print, what the output of this program is, it'll print hello world, hello world. If I remove the ln here and I remove the ln here, it will go hello world on the same line. Okay, and I'll show you that in a second. The round brackets, as I mentioned, are going to define input. What do you send into this command? And then we've got this quotation here, hello world. When you use quotation marks inside programming languages, it is like what a quote is meant to be in the English language. Do this verbatim. Do this exactly as I've written. So if I've a terrible habit of doing this. If I start a word with a capital letter, just because I don't take my finger off the shift key fast enough, I usually capitalize the second letter as well. So I get capital H, capital E, LLO, hello. So if I've done that and I've made a mistake in how I've typed it, or I've misspelled a word, the computer assumes, oh, it's inside quotation marks. That's exactly as you want it. You're meant to be the intelligent one here. You must have meant that to happen. Computers do not have any decision-making skills in that sense. And then we close off the bracket, so that ends the input here. And then a really, really important character inside programming is this character here, which is a semicolon. And the semicolon is how you signify this is the end of this command. And every command has a semicolon at the end of it. Not every structure. If you notice, we don't have a semicolon at the end of the method. We don't have a semicolon at the end of the program because they're not really commands. They're ways of collecting information together. But the actual commands, they must end in a semicolon. Okay. Yes.
Just to reiterate, the second line of command you were saying, we're going to use that every time. Is that correct?
This one here?
Yeah.
Yeah, absolutely.
Okay.
There would be, for the first, it'll become redundant pretty quickly because you're going to get enough practice, but for the first couple of weeks, there will be no harm in taking that down, and every program starts off this way, and then you delete the bits you don't need and add in the bits that are new. And that's actually what we're going to do tonight. We're going to take this program here, and we're going to print it out and make sure it works, and I'm going to show you how to build it and then run it. And then we're going to change it. Get it to print out your name. Get it to print out your name and your student number. Get it to solve a mathematical equation. We're going to keep augmenting the code as we go along. But that basic structure, you can take that as a template and then change from program 1 to program 2, the next program you do, and so on. Yeah. Any other questions? No. Okay. So what I'm going to do now is I'm going to hop out of the slides, and I'm going to give you a worked example so you can see how it's working and how we go from, well, that's the text I want to do, to actually getting to run the code, okay? Before I do this, because I'm going to go slowly to make sure people can tag along, can people log on to the machines? Does anyone here, if they cannot log on? You can't log on at all? If you can't log on, could you attempt to show me the error? So your password is going, or your username is going to be your student's email address, and then your password will start off your name. That's cool. All right. Okay. Cool. All right. Okay. If you want to turn your camera on, I'll show you how to run through the installation of that. You can't log on either. Okay. Okay, what's the error you get? You're getting very few errors there, so I think I just little line here. Sorry. Get there. Security database does not have this computer. Okay, when did you register? Okay, all right. I don't know what's up there. I would suggest that for today, I like one first name and see if that works. You did log in yesterday. Maybe. We'll try to log it in like and see. Okay. So this might be nothing to do with your account. No, this will be this machine. Okay. So you have a choice of either moving to a different desk or looking at someone else's machine. There. Okay. And install Java. Okay. Cool. What I want you to do is I want you to follow along what we're going to type on the screen, and then I'll come down to this to make sure. Mac is great because usually when you install Java and you have it in there, it automatically links it. So that weird linking stuff you need in Windows, you don't need that. What do you get there? Okay, right. So first of all, the email address is and there's usually a dot between your first name and your last name. Yeah. Okay, so try your password now. Anybody who has this is my 5-scroll forward. Anyone who has their own laptop, what's going to happen is later on, when we run through this, I'm going to give you work to do yourselves. I will make sure that your laptops are all up and running before we leave the lab. And that way we will be able to slowly get everybody set up for work at home. Okay. It's not working. Let's see if I can log you in there. Very possibly, if you only have registered today, that hasn't been true. Okay, that'll log you as me and then you'll be able to follow along. Okay, so what I'm going to do is I'm going to open up Notepad++. That's the environment I'm going to use on my machine. However, I know on the Moodle site I've recommended Atom or Sublime Text as well. If you have a Mac, they're also good options. Okay, so what I'm going to do is I'm going to create my program here. I'm going to call it class hello world. I'm going to open my bracket there. And then I'm going to go tab in one space. Public static void main string square brackets args. And then I'm going to have system.out.print hello world. Okay, so that's our really, really basic program. At the moment, that text is all black and white. Okay, I haven't saved it. I've been through this lab with the full-timers, so I'm going to assume that none of you are going to make these mistakes, but I'll highlight the mistakes that the full-timers make. A couple of things here. Hello world, there is no space in that. Okay, so it's capital H, E-L-L-O, and then immediately the next character is W. There is no space between the end of hello and the start of world. This word here is public static void. They are all lowercase. This word here is main, lowercase. This string here has an uppercase S. That is an uppercase S for system. That is a full stop. That is a full stop. And that's it. Okay?
We don't have to put the line.
We don't have to put the
Put the line LN.
For the moment, no, I'm going to do, there are two commands I'm going to look at. I'll start with this one and then I'm going to change it to ln so you can see what's happening, okay? Okay, so that's me. I've typed out the code that I want. The next thing I need to do is I need to save that code. Now, you're definitely not going to be able to see this from back at the back of the room. So what I'm going to do is I'm going to click on File and I click on Save. It generally opens you up to Notepad++. You are not going to be able to save there. So I'm going to click on Desktop, and that's where I'm going to save my information, okay? It makes it easy for me to find it. It also means that at the end of the class, any of you who are using the college machines and you want to take your work home, it makes it easy to locate it, to pull it off, okay? If you leave your work on these machines, that's fine. But if you come back next week and you're sitting at a different desk or sitting at a different machine, you will not have access to that machine. Okay, I would advise acquiring a USB key or emailing yourself the code or uploading it to Dropbox or to OneDrive or to Google Drive at the end of each class to make sure you keep a backup of it. Okay, and I'm going to call my file Hello World, spelled exactly the same as I've written it up here. So see the way up here? I've written Hello World, all one word, capital H, capital W, everything else lowercase. That's how I've written my file name. For first year, it is an incredibly good habit to develop that your file name always matches what goes up here. Okay? It's one of these things which technically you don't have to do, but from a beginning programming point of view, it makes life really complicated. You can get into real complications with silly mistakes if you don't do this. So I would always develop the habit of your file name is always going to match that, and you're going to put in the extension of .java. If you don't put in the extension of .java, if you just type hello world and press save, it saves it as a text file. It will remain black text. However, when you put in the .java extension, you'll see that the text has changed. I now have some blue words. My brackets are blue. The full stops are blue. The semicolon is blue. If you're getting that, that means you saved it as a Java file. If it's remaining as black text, you need to go up to File and go Save As and make it Java. Okay, so while people are taking that down, this is step one of our three-step process to get a program working. So step one is write the source code and save the file. I'll include that as part of the step. Once you've written your source code, the next step is I need to build my source code. I need to run it through my Java compiler to make sure that it's syntactically correct, the grammar of the programming language is correct. You can just click cancel that. If Notepad++ says, hey, do you want to install updates? Just go no. You're not administrators, so you won't be allowed. So we need to compile our program, and that's going to convert the English-like language that we have there into machine code. The idea of Java, and I can't remember if I mentioned this to you guys last week, is that it is platform independent. And the idea of that is that I'm going to build it once, and I'm going to run it anywhere. I can use the Java virtual machine to convert the code I've written on the screen there to a series of ones and zeros, and then I can take that to my current machine and I can run it. I can copy it onto a USB stick and run it on this desktop here. I can copy it onto a USB stick and bring it down to someone on a Mac and run it on a different operating system. If you have an Android phone, you can load Java onto that. You can run it on that as well. I can run it on a Linux system. One of the big pushes for Java is to make it platform independent. Build once, run anywhere. That's the second step. We have to build our program. The build step is the one where you're going to find out, have you made any what are called compilation errors? Have you written the syntax? Have you written the commands incorrectly? If you have written the commands incorrectly, it's going to come up with a list of errors trying to help you to resolve that. And then the last step is actually running the program. If we build it, if we compile it, and we don't get back any errors, then great, we can go ahead and we can run it. So, I'll assume that most people are okay at this point, and if not, I'll draw it back up on the screen in a couple of minutes. The next thing I want to do is I'm going to open up my command prompt. In Windows, I'm going to hit the Windows key, and I'm going to type CMD, and it gives me command prompt up at the top. If you're on a Linux machine, it's your terminal. If you're on a Mac machine, it's terminal. So on a Mac machine, you're going to hold down that weird Celtic symbol. I think is it Apple or Control and space, and it'll bring up a search bar. If you just type in terminal, then it'll bring you up to the terminal, and it's going to save, or it's going to open up something that looks like this. I think I mentioned this last week. If I didn't, I'll reiterate it. This is what your operating system is. Behind the nice desktop images and the buttons and the widgets and telling me if I'm connected to team sharing here and showing me how much battery I've left and my Wi-Fi signal and the volume and my start button down here. Behind all of that, there's just a text-based system. And all operating systems work like this. And as a computer scientist, it's kind of important you've seen this at some stage. And so what I do is I take a somewhat backwards approach to building and running our programs by forcing students to go through this interface. There are other platforms, even with Notepad++, you can get built-in scripts that will build it and will run it for you just by a click of a button or a drop-down menu and click an option. But what I want is I want you to be familiar with this. We're going to use a couple of commands. It's not a huge amount. I have a YouTube video up on what those commands are on the channel. But it's important that you get some exposure now. And maybe in second year, you get a little bit more exposure. And then third year, actually in third year, you will end up getting more exposure anyway. But what happens is on third year, or in third year, or in fourth year, as you start to get ready to go out into industry, you start looking at these jobs. And maybe programming wasn't the thing that you liked most on the degree. Maybe you loved the idea of building and configuring networks and servers and maintaining all of that stuff. And if that's the case, if that's the route you've gone down, hey, I'd love to be in charge of like the college's network, knowing that all the software on the machines is updated and that the email system's working and managing those servers and making sure that we can access our email via our mobile phone from Paris, from the other campus, from wherever. If you want to go down that route, you need this command line experience. And we've had students in previous versions of the course where I didn't do this, where we just did, hey, yeah, press the play button and it builds it and runs it for you. We've had students get to their final year of their degree and never have looked at a command line. And so let's do a fourth year student, someone who's meant to be going out into the workforce. You open up something like this and you ask them, you're on the C drive here, you're in users, you're in no one. Go into the desktop. And they had no idea how to do it. For us, that's our first command. That's what we're going to do. So that's why I do this. It makes it a little bit long-winded, but I can guarantee that you're going to get into a really good habit of working your way between your development environment and this terminal, going back and forth, and a nice kind of workflow to be able to work through development. And this will stand to you as you go into second year and third year and look for work in industry. So as I said, our first command is going from this location here to our desktop. Where I am here, I'm on the C drive. That's our main hard drive of the computer. If you're on a Mac machine, it doesn't tell you what letter drive you're on. You're just on the main hard drive. I'm in a folder called users, and because it's my computer, I'm in a folder called Owen. That's the account I've logged into. If I were to show you what this looks like in Windows Explorer, where you might see it more familiar, I'm on the C drive. I'm in a folder called users. Let's go view extra large icons. And I'm in a folder called Owen. And view extra large icons. So I'm here. This is all the stuff that I have available for me. I've got 3D objects and I've got app data and Canon and documents. Hey, Alex.
Sorry, just a simple question.
Yes. No. So we use your email account. Your email account only works.
But anyone who's not registered,
They have no access.
that's no vote.
Yeah.
That's not just check. Thanks, sir.
No worries. So I've got all of these folders here, and I can see them. And again, because we're used to the Windows interface, I can click on this one here. So I can click on, where's my desktop? There's my desktop there. I can click on that, and I can see that's my file I want. View, extra large icons. There's the file I want. That's my Java file there. But you can't do that in command line. You can't just click on something. So what I want to do here is I want to change my directory to go from where I am into the desktop folder. The way we do that is we type CD for change directory, and then we type desktop. Actually, because we're in a long room here, I'll make the font slightly larger again. 48. Okay, so CD desktop, and when I hit that, you can see that now my location is not C drive users Owen, but it's C drive users Owen desktop. And when we have this greater than symbol here, that's where I can type my next command. Okay, so that command there, all I've done is I've moved from one folder into a subfolder. I'm not going to go through it today. I'll add in, I'll do the bare minimum of commands today, and then next week I'll add in one or two more, and next week and the week after that I'll add in one or two more, and then we're pretty much finished. You should be happy to be able to move yourself around in this system. This is where my file is. There is one command I can do to check the contents of that directory, and I can type dir, so Delta Indigo Romeo, and that will give me a list of all of the stuff inside my desktop. I've got a folder here called code to be sorted. I've got a Java file here called helloworld.java. I have an Excel spreadsheet here called L8 space year 1. I have a PDF scan. It gives me the size of each of the documents. It tells me when they were created. It tells me the time there. It tells me if it's a directory or not. If you're on Mac, it's ls for this command, not dir. Yes.
So I made a mistake.
Okay.
So how do I go back?
So you made a mistake. Oh, no, you don't have to go back. So what you do is the CD space. You actually haven't moved anywhere because there isn't a folder called CD.
Yes, exactly. So
if you go, no, that's it. That's as far back as you can go there. So.
Okay, so I have to close.
No, you're okay. So if you type CD, and then space, and then desktop.
Oh, okay, so I have to run it.
And there you are. Okay. So this is the file that I'm interested in. That's my Java source code, what I've written as the programmer. And I need to convert that into a Java program, into a class file. The way Java operates is we have something called a Java virtual machine. This is what allows the build once, run anywhere idea. The Java virtual machine is what's installed when your system can run Java. And it can take a file with a .class extension and it can run it. It can perform whatever actions are inside that program. And so I need to make, there is no class file there, so I need to make the class file. So here is step 2 of our system. Step 1, write the code. Step 2, builds the file. So I'm going to use a command called javac for Java compile. And I'm going to put in the name of my Java file, helloworld.java. And again, just to point out, I'm going to hammer you with this today to make sure that people get it into their heads. Look at the way I spelled helloworld.java. There are no spaces. And if I was to flick back to my code, it is exactly how I've written it up here, capital H, capital W. Of the 50 students I had for full-time, at least 10 students got either putting a space in the name or spelling it differently or having something completely different. The fact that they're linked, the fact that they're similar is quite important. Okay, so I'm going to type javac space and then the name of my file, which is helloworld.java. You can see it up here. And when I press enter there, the computer pauses for a moment or two as it's building, and then if everything has gone smoothly, I should just get the prompt back. It doesn't give you an output going build successful. It just says, okay, no error messages. Okay. Okay, so it's going to be CD desktop. Right, and then CD space desktop. Yeah, that's it. And then you're going to go with the command I've written there, Java C. Okay, so I'm going to go quickly around to see what people's outputs are there. Yes. So Java compile is converting your Java file, the code that you wrote, into a program that actually can be run. Okay? Is anybody getting any weird errors? You got one error there. Ah, perfect, yeah. Okay, so any of you who've got an error, and we're going to look at a couple of errors after the break, but any of you who've got errors when you run them, they're kind of verbose. They tell you where you may or may not have made a mistake. Excellent. And you can fix it now? Yeah. Perfect, okay. So far, I've seen two people have a mistake on their command prompt, and both of them have fixed the problem based on the input they've got back, or the output they've got back. Yeah, so you get the whole I actually use that to see if it's installed properly. Okay. Yeah, that might be. You're in one side. Okay, all right. I'll be down to the moment. Yeah. Oh. Okay. So what you're doing is just going to use an app now. Okay, and so we're going to go back in here. We're going to go save. You're going to do this, or you can go file and save. And then you can go back and go into command again. Yep. Oh, okay. That's because your machine, don't worry about that for the moment. That's something I'll fix. Okay? Okay, there. Okay, excellent. Right. So, again, from quickly going around, most people have got it. The command has worked. And where the command didn't work, where there was an error, there was enough information given back to you as a developer to go, you're missing a bracket, you're missing a semicolon. This name doesn't exist, so maybe you misspelled the name. Okay? They're sensible error messages coming back. And we're going to look at a couple of the error messages to kind of identify what they are. If you build your program and you get error messages, it has not built that program for you. That program doesn't exist. It started to make it and it stopped and said, oh, I've got a problem here. That's not working. So it stops at that point. If you get this, where you run the command and you get no output out, it just brings you back to this cursor. That means that everything has gone smoothly. And the last step is that we are going to run the program. So we have written the program. That's the code we've written. We've built the program here. I'm lucky, there haven't been any errors to fix, but for those of you who did get an error, you fixed the error, you saved the file, you rebuilt the program. And that's a key point. Every time you come up with an error, if you fix it, you need to then run this Java C command again to rebuild, to make sure, are there any mistakes now? And keep doing that until you get this empty response here. And then the last command we're going to do is we're going to go Java hello world. We don't have any extension there. And if I do that, I get the completely underwhelming response of the output of my program, which just says hello world on the screen. So, what I'm going to do, we have about 10 minutes or so, we're going to do a break. I'm going to shut down this window, open it back up again, and do those 3 commands, so you can see them all on one screen to make sure that everybody's okay with this. So hang on 1 second. Down. CD. Okay, so first command was CD desktop. Second command was Java C hello world. Third command was Java hello world. Okay, so there are 3 commands. So if you haven't got through those 3 stages, they're up on the screen now. I'm just going to quickly run around the room to see that everybody's got to that point. If you have, if you have got to that point where you've run the program that says hello world, edit your program to print out your name. Okay, the trivial change if you've been able to do this so far. Okay. So hello world, try to see hello world. Okay. Okay, all right. You had an error there. You fixed the error. Yes, if.
We can have
Right, okay, so you see there the public was spelled with two I's rather than a U. Okay, so we go back here. So that looks all correct. It's called Hello. Right, okay. You call this Hello World with capital H and capital W. What you call the file a world with all lowercase. They are
it
case
makes it
sensitive.
where it's
Yep.
when you say-
So the quickest way to do this is just close that window there, it's saved, it's changed the file name here. Okay, right. Yeah. See how they touch. So you have a hello world and you've got a hello world here. That all looks correct, okay? So here, run this command, hello world, great. The case does not have there is right. So your code is correct, it's just the commands are executed was slightly off. Okay? You're okay there, yeah, okay, great. And you get errors, you fix them. Cool. You're fighting the Java. You have two W's in Hello World. You're getting 4 errors. Cool. All right. That's all right. So, the errors that you have there, if rather than going that key there, use that. Okay, right. Hello World in very line number 1 at the start. It's all right. Honestly, the first 10 programs you're going to do, most of the mistakes will be typing errors. They'll be spelling mistakes. And it's just the learning curve. That's good. Now, if you haven't changed this up here, which means when you go to run the program, it still needs to be called Java CD1. But it'll print out the new version anyway. There.
No.
Right. Hang on a moment, and what I'll do is I'll do the link for you. Okay. Oh yes, because well, you have to save right here. I mean, you have to save it, and then rebuild it, and then run it again. How are you getting on there? It's PDF. Oh, no, yeah.
Not Java, it's probably just link for PDF.
That's yeah. Okay, that's open with right, okay, is that was just the icons associated with it. Right, you can have it in Java, so it's working. And it's working. Excellent. Okay, that's brilliant. So apart from a couple, did you get your yet? Yeah, great. Okay. So apart from people who brought their own laptops, just need that link gone from where Java is installed into our operating system, which I'm going to quickly run around and do now. Everybody's been able to get their very first program written, built, any errors that might exist corrected, and then run the program. That's fantastic. Okay, if that's all we achieve today, that means that things will be smoother going forward after this week. I'm going to stop here because what I'm going to do is anybody who has their laptop who's installed Java but it's not working for them, I'm going to quickly make that link for you guys so that it works. And then when we come back, I'm going to go through explaining what we've done with these commands here, and then I'm going to give you a couple of challenges to do, and we'll spend probably the last 40 minutes of the class working through code again. Programming is a practice-based skill, and I'm going to give you an awful lot of practice. Okay? Because you will learn the mistakes you're getting now and the confusion. Why is that coming up? I don't understand what's coming up. In 2 weeks' time, you'll be far more comfortable with it. In 10 weeks' time, you'll be really comfortable with it. And I'm hoping in 20 weeks' time, they won't be an issue anymore, and you'll have much more difficult problems to solve because you'll have more experience and you'll be more versed in the actual idea of Java. Okay, just about quarter to now. If you want to come back at 8:05, and we'll resume then. I'm going to kill off this YouTube feed, and I will restart it then when we come back. End stream. End.